Let's first look at question 31. We have to factorize x cube plus x minus 3x square minus 3. We can quickly see there is some x and 3 and x and 3. Why don't I rearrange the terms? Let's bring 1 and 3 together and 2 and 4 together, the terms. I can also write it as x cube minus 3x square plus x minus 3. Is there something common here, right? X square can be taken out common. What would I be left with? X minus 3. Plus I can take out 1 common from these two because there is nothing else which is common between the two. I can move, I can take out x minus 3 common, and what am I left with? X square plus 1. I cannot factorize this any further, so the final factorization will be x minus 3 into x square plus 1. Let's look at the next question, which is the 34th question, which says x cube minus 12x into x minus 4 minus 64. Let me first open the bracket. What do I get? X cube minus 12x square plus 48x minus 64. I'll scratch my head a little bit and I'll see that this is a cube as well as 64 is a cube, right? This is a cube of 4. I see a cube. I see two cubes. I see a minus sign. The next thing that should flash in my mind is it x minus 4 whole cube? Can it be? And you try and do the reverse engineering here. Let's see what would this be equal to. This would be equal to x cube, fair enough, plus 3 into x square into minus 4 plus 3x into minus 4 whole square plus minus 4 whole cube. What is this equal to? X cube minus 12x square plus 48x minus 64, right? This is what it is. So as soon as you see two cubes, this either a plus b whole cube or a minus b whole cube should start flashing in your mind. Fair enough, and then you can do the reverse engineering bit. Let's look at question 36. It says factorize a square minus b square whole cube plus b square minus c square whole cube plus c square minus a square whole cube. Now whenever such a question comes, we have to look at, see, there are cubes of 3 terms here. Now whenever we have cubes of 3 terms, remember there is an identity in there. What is that identity? X cube plus y cube plus z cube minus 3xyz is equal to x plus y plus z into x square plus y square plus z square minus xy minus yz and minus zx. Now this looks like a very big identity, but the majority of the use of this happens when x plus y plus z is equal to 0. Now if x plus y plus z is equal to 0, the entire right hand side, the longer part, becomes 0. And then we can say that x cube plus y cube plus z cube minus 3xyz is equal to 0. And from here I can say that x cube plus y cube plus z cube is equal to 3xyz, and the condition for that is x plus y plus z must be equal to 0. Fair enough? So whenever you see 3 cubes, what you have to do is find out which one is your x, which one is your y, and which one is z. And the first thing that you should be doing is finding out the value of x plus y plus z cube. What the hell is this equal to? Now in this case here that you've asked, x plus y plus z will be equal to a square minus b square plus b square minus c square plus c square minus a square. And clearly you can see all of these will cancel each other out, and this indeed will be equal to 0. So in this case what you will get, that x cube plus y cube plus z cube must be equal to 3xyz. If I put the values here, this will become 3 times of a square minus b square into b square minus c square into c square minus a square. And then this is a standard thing that you can do, 3a minus b into a plus b into b minus c into b plus c, and continue it to c minus a into c plus a. And this will be your complete factorization.